Hello everyone, welcome to this video on the equations. So this is the second part of this equation series in the algebra topic. In the earlier video of equations, we have talked about the linear equations and solving them. In this video, we are going to talk about the quadratic equations in depth and also a bit about higher order equations like cubic beyond that. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you're watching this video in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of course and also get to practice a lot of questions after that. So let's get started. So first, what is a quadratic equation? Right, so we know the linear equations, like if I say 2x plus 3 is equals to 5, so 2x is equals to 2, x is equals to 1. You see, this is a linear equation because there's one variable, that's x. I only see one variable here, but the important thing, what defines it as linear is the power of the variable is 1. The highest power is 1. A quadratic equation of one variable would look like this. Generally, ax square plus bx plus c is equals to 0 is the format we see. Like for example, x square minus 4 equals to 0, or 2x square plus 3x plus 6 is equals to 0. All of these are quadratic equations. You see, this one is clearly like ax square plus bx plus c. This does not look like that, but you have to understand like this: ax square plus 0 into x minus 4 equals to 0, and a is 1. So it's basically 1x square. A is 1, b is 0, and c is minus 4. That's how you sort of read this. The important element is this: the highest power of this variable is 2. You won't see 3, 4 or 1, etc. like that. This is called the quadratic equation, right? And equation equals to 0. Even if you see something like 3x square plus 6x plus 6 is equals to minus 4, you need to send this side and get it as 3x square plus 6x plus 10 equals to 0 to solve this equation in the way that we generally know, right? So a quadratic equation would have roots or solutions. Roots or solutions are basically the values of x which will satisfy the given equation. What do I mean by that? So if I put x, for example, right, let me take an example like x square plus 2x plus 1. There is a simple example. So this is a quadratic equation. If I put x is equals to minus 1 square plus 2 into minus 1 plus 1. What is this? 1 minus 2 plus 1. So 1 plus 1 is 2 minus 2 is 0 is what the right hand side is saying, right? So LHS is RHS. So that's why I'm saying x is minus 1 is satisfying this equation x square plus 2x plus 1 equals to 0. If I put x is equals to 2, for example, 2 square plus 2 into 2 plus 1 is 4 plus 4 plus 1 is 9 is not equals to 0, right? So x is equals to 2 is not satisfying this equation, hence 2 is not a root, of this equation or solution, right? So what values of x would satisfy this equation? Those are called the roots or solutions. If you remember for linear equation, right, if x is 1, that will satisfy this 2x plus 3 equals to 5. So 2 into 1 plus 3 is 2 1s are 2 plus 3 is 5, that is equals to 5, that is being satisfied. For a linear equation, there will be one value which would satisfy, but when it comes to quadratic equation, we will have generally two roots. Right, let me take an example: x square then plus 5x plus 6 is equals to 0, right? The roots are minus 2 and minus 3 for this. So if I do minus 2, substitute here, minus 2 square plus 5 into minus 2 plus 6 is minus 2 square is 4, 5 into minus 2 is minus 10 plus 6, 4 plus 6, 10 minus 10 is 0. So this is correct. Let me check minus 3. Minus 3 square plus 5 into minus 3 plus 6, so minus 3 square is 9, 5 3s are minus 3s are 15, minus 15 plus 6, 9 plus 6 is 15, minus 15 is 0, that is also a correct root. I didn't do for this question because the roots of this are both minus 1 and minus 1, so there is a chance that there will be only one value which will occur as twice. So basically there is only one root as well, right? That's how we say that there will be minus 1 appearing twice to get a quadratic equation. But generally the maximum that a quadratic equation will have is 2 roots. Sometimes it will have only 1 root which is repeating twice. Sometimes you might have 0 real roots as well, right? The complex roots are of form a plus bi. So just to clarify, square root of -1 is I. You don't have any number coming out because no square would give me -1, -9, etc. -3 square or +3 square will not give me -9. Both of them will give me +9 only. So for that reason we call the imaginary number is the value for square root of -1. So when we go into this sort of stuff, it is called complex numbers and complex math, and they would not count complex roots. For this case we do not count them as roots, or rather 0 real roots, 1 real root and 2 real roots. We generally do not see in normal exams talking about complex. We get to see them in advanced math, but we don't touch them in the exam, so don't worry about that, right? So that's what we basically I mean by the root. So how do I find the root? A simple formula, we'll get to that. So in quadratic equation we have talked about the roots and solutions. How to find the roots when quadratic equation is given? You see this x square plus 5x plus 6, I gave the roots as -2 and -3. So let me show how we can find the roots. The formula way is this: the roots are -b plus or minus square root of b square minus 4ac by 2a. That is for the expression ax square plus bx plus c is equals to 0. In this case, what is a? A is 1x square, b is 5 and c is 6. So -5 plus or minus, see plus is one root and minus is another root. As I said, we'll have 2 roots, that's why we'll put plus or minus. B square is 5 square 25 minus 4 into 1 into 6, that is 24 by 2 into 1. So -5 plus or minus 25 minus 24 is 1, square root of 1 is 1 by 2. So basically I'll have 2 roots, -5 plus 1 by 2 is 1, -5 minus 1 by 2 is 1. That's the meaning of this, right? Plus or minus. So -5 minus 1 minus 6 by 2 is -3, -5 plus 1 is -4 by 2 is -2. So the roots are -2 and -3. Right? That's one way to find. The other way is to factor it. You see, take the coefficient here and take the coefficient here. That is basically a and c. Right? 1 into 6 is 6. Split them into factors. Right? For example, 3 and 2. Or I can also make sure you can also do like minus into minus. If I see the product of this and this positive, both the factors have to be positive or negative. If I see the product as negative, one of them positive, one of them negative. Right? It could also be 1, 6, etc. Right? But you see, this will satisfy this. 3 2s are 6 and 3 plus 2 is 5. You also have to be careful about the sign. If it was -5, right, x square minus 5x plus 6, it would have been -3 into -2 is 6. -3 plus -2 is -5x. That would have satisfied. But because I see plus 5x, so I rather split it as 3 and 2. So the roots are 3 and 2. Sorry, the factors are 3 and 2. So I'll get them to be x plus 3 into x plus 2. Once I write them, the roots are x is equals to -3 and -2, which is what the roots are. That's like factoring method. If you know this already, you will find this much easier. All you need to do is see 1 into 6, so the answer is product is 6, split them into 2 numbers such that the sum should satisfy this value, so that I can factor directly like this. If you are not understanding, if you are not comfortable with this, don't worry, stick to this, you will get the answer. You will get the same things. How to find the equation when the roots are given? Let's say the roots are alpha and beta. If I give you the roots, for example, I give you the roots as -2, -3, how do you write the equation? If I give the roots as alpha and beta, all you need to do is the expression will be x minus alpha into x minus beta. This is the quadratic equation for which the roots are alpha equals to 0. This is the equation for which the roots are alpha and beta. So just multiply them how we do in normal algebra. X into x, x square. X minus beta is minus beta x. Alpha x minus alpha x. Minus alpha into minus beta is plus alpha beta equals to 0. So I take x common in this, so it will be alpha plus beta x plus alpha beta is equals to 0. You see this being written like this. Alpha plus beta is sum of roots. Alpha beta is product of roots. Right? So x square minus sum of the roots into x plus product of the roots equals to 0 is the expression. If I know the roots are minus 2, minus 3, how would this expression look like? X square minus sum of roots minus 2 plus minus 3 into x plus minus 2 into minus is product of roots equals to 0. Minus 2 plus minus 3 is minus 5. But I see minus outside also. So minus of minus 5 is, let me write like this. I'll get minus 2 plus minus 3 is minus 5x plus minus 2 into minus 3 is 6 equals to 0. Minus of minus is plus 5x. So x square plus 5x plus 6 equals 0. I can write it directly like this, right? Using this formula, x square minus sum of roots plus product of roots equals to this, right? Or as I said, I can straight away start with x minus of minus 2, x minus alpha, I know the roots is minus 2. So x minus of minus 2 is x plus 2. Similarly, x minus of minus 3, because other root is minus 3. This will become x plus 2 into x plus 3 equals to 0. And then do the multiplication, you'll still end up with x into x square plus 3x plus 2x plus 6 equals to 0. That will give me x square plus 5x plus 6 equals to 0. Right, that's the same thing. That's how you do it. So this formula would be useful the way you look at it, right? Sum of the roots and product of the roots. If I say, I don't give you the individual roots, but I say write the quadratic equation for which the sum of roots is 6 and the product of roots is 10. Then the equation would like x square minus 6x plus 10. Because as I said, x square minus sum of roots 6 into x plus product of roots. So the equation would be x square minus 6x plus 10. I don't know the individual roots alpha, beta. I don't need to know. I can just play with this. So this is also a useful thing to understand and keep in mind, so that sometimes the questions could test you on this concept as well. Right, then coming to the nature of the roots, which I have discussed, right? So a quadratic equation at max will have two roots or two real roots. That is what we are worried about or have some concern for. So there is something called discriminant. So discriminant is b square minus 4ac. So if that is greater than 0, right, I will have two different real roots. Why would this occur? Let's look at the roots, right? What are the roots? Minus b plus or minus square root of b square minus 4ac by 2a. See, this is discriminant, right? So it is like basically saying minus b plus or minus square root d by 2a. If d is positive, then square root of d is square root of some positive number, will give me a real number as output. So I'll get minus b plus or minus some real number by 2a. So I'll have two different roots, minus b plus square root d by 2a, minus b minus square root d by 2a, and both of them is root 1, root 2, and both of them are real roots. And they are two different real roots. That's why I'll get two different real roots. If discriminant is 0, what will I end up with? Minus b plus or minus square root of 0 is 0 by 2a. So the root will be minus b by 2a. I don't have plus 0, minus 0. Both of them will be same, minus b by 2a, minus b by 2a. So what will I end up with? Real roots, yes, two real roots, but they are equal. So it's basically only one unique root, but they look like two. Why would I call them two? If I ask you to write the quadratic equation for, if it has root minus 1, minus 1, it is simply x plus 1 into x plus 1. So that reason I need to count that there are two. Otherwise, if I only count one root, I will end up with only x plus 1 as the equation. X plus 1 equals to 0. But that is not a quadratic equation, right? For that reason, I should understand both of the roots are existing, minus 1 and minus 1. But it's the same value. That's why they are equal roots. If discriminant is negative, so minus b plus or minus square root d by 2a. If this is negative, I will end up with square root of minus something. So that will give me imaginary number, right? Minus b plus or minus something into imaginary by 2a. This is all complex stuff. So which is not real roots. That's why I'll end up with two complex roots. So they might ask questions like, if there is a quadratic equation 2x square plus kx plus 6 equals to 0, for what value of k would that give me two different real roots or two real roots which are equal or two complex roots? All you need to do is just make sure b square minus 4ac equals to 0 for two roots which are equal, or greater than 0 for two different real roots, or less than 0 for the complex roots. So b square is k square minus 4 into 2 into 6, right? And then you will get to a k square minus some value, then solve it like a inequality and get the value. So roots for higher order equations, right? So we have talked about quadratic till now. The basic principles would work for higher order also, like cubic, beyond that, like with the power 4, 5, etc. just revise, the chance of seeing higher order is low, but the way to look at is this. If you have seen our basic algebra video, we've talked about factorizing higher orders, right? That is, if I give you x square plus 2x plus 2x square plus 3x plus 6 is equals to 0, how I can write x minus something into x minus something into x plus something or whatever, something x minus minus. So this is how you factor it. Understand this, when I say x minus 3 into x minus 2 equals to 0 is the quadratic equation, the roots are 3 and 2. What do I mean by that? See, I am multiplying two things. The product will be 0 when one of them is 0. So 0 into 10 is 0, 0 into anything is 0, or something into 0 is 0. So either x minus 3 should be 0 or x minus 2 should be 0. So when x minus 3 is 0, what is x? X has to be 3. Or x minus 2 is 0, x is 2. That's how we find the roots for this. If I can factor a cubic equation like this, right, x minus 1 into x plus 2 into x minus 3. As I said, a quadratic equation would have 2 roots at max. A cubic will end up with 3 cubic roots max. It won't have 4. It can have 2. What do I mean by 2? Basically, it will have 3 real roots with 2 of them repeating and 1 of them being, I can have an expression like x minus 1 into x minus 1 into x plus 2. What are the roots here? X minus 1 equals to 0 gives me x is equals to 1. This is x is equals to 1, x is equals to minus 2. The roots are 1, 1 and minus 2. So there are 2 roots which are distinct, but on the whole, actually the equation has 3 roots. Right? For example, in this case, what are the roots? I have 1, minus 2 and 3. So 3 distinct roots, 1, minus 2 and 3. This is also possible. So if I ask you to find the roots, so if I can factorize them, I can do that. Right? That's one way to look at this. What is the other way to look at it? Sometimes you might get a question asking, if I say the roots of a cubic equations are 3, 6 and 5, or okay, let me show this, right? 1, minus 2 and 3, what is the cubic equation? So if I have a cubic equation, I generally have 3 roots, right? Alpha, beta, gamma. As I said, it will go like this, x cube minus the sum of the roots into x square plus product of 2 roots like alpha, beta plus beta, gamma plus alpha, gamma. Right, alpha, beta, beta, gamma, alpha, gamma. Right, I multiply 2 of them for 3 times like alpha, beta, beta, gamma, alpha, gamma into x, again minus product of alpha, beta, gamma equals to 0. That is how I write the equation. What did I do? You imagine for the quadratic, if it is alpha, beta, what did I do? X square minus the sum of them alpha plus beta into x plus alpha into beta equals to 0, right? You see, minus plus, here I am doing minus plus minus. If it was power 4, I would have done minus plus minus plus. It will go like that. Clear? And also if you see this, alpha plus beta plus gamma, that is only one term in each of this. Alpha, beta, 2 terms. And here 3 terms. Sum of the roots, sum of pairs of roots, product of pairs of roots, and finally the product of the roots. That's how I can write. If I have to write for higher power, for x power 4, it will be x power 4 minus alpha plus beta plus gamma plus, let me put delta, right, like something like this, 4 roots alpha, beta, gamma, delta into x cube. You see, I start off with minus sign plus 2 products alpha, beta, alpha, gamma, alpha, delta plus beta, gamma plus beta, delta plus gamma, delta. I will have 6 products x square. Again I will get minus with 3 alpha, beta, gamma, alpha, beta, delta, beta, gamma, delta. Right? Into x cube, sorry, x into x. See this, is this it? Alpha, beta, gamma, delta, right? Alpha, beta, delta, alpha, beta, gamma, delta. Everything else would be repetition of this, right? And finally, plus alpha, beta, gamma, delta equals to 0. I know this is like really messing up. Don't worry if you are not understanding this, but if you understand it, that's good. You can do any higher order. The chance of seeing anything beyond quadratic is very low and beyond cubic is almost nil. So don't worry about it. Just get the sense of solving any equation is once I can factorize it, these will be the roots. Once I know the roots, if I know roots, I can find the equation in this way. Or sticking simple format, forget about all of this stuff, okay? If I know the roots is alpha, beta, gamma, or 1, minus 2, 3, what did I say? Just do x minus 1 into x plus 2 into x minus 3, right? 1, minus 2 and 3 are roots, so x minus 1, x plus 2 and x minus 3, multiply them, you get the answer and that's it. That is also fine if you get to solve it. But just get this perspective how you can extrapolate your understanding of a quadratic to a cubic or higher powers. That's what I'm trying to tell. Even a little bit of understanding would do a good help for you. If you are confused, just rewind and see this again. It might take a bit of understanding and time to understand actually. So let's get with some problems. As we always say, pause the video, try this on your own, then follow with us and see the way to solve it, right? Hope you passed. So find the value of p if x is equal to 3 is the root of equation. As I said, when I say something is root, that means if I substitute that value into the variable, it should satisfy the equation. 3 is a root, so 2 into 3 square minus 3 into p into 3 plus 9 should be 0. So 3 square is 9, 9 2s are 18, minus 9p plus 9 equals to 0. So 18 plus 9 is 27, minus 9p goes this side, becomes plus 9p. 9 1s are 9 3s are p is, so p is 3. That's it. That's how you need to find. Find the roots of the following equations. So here I see higher power 2x power 4 minus 15x square plus 18. But you see here there's a simple way to do this. If I take x square as a, another variable, what would this turn out to be? 2a square minus 15a plus 18 equals to 0, right? Why? Because I am taking x square is a, so x power 4 is written as x square whole square, that is a square. X square is a. So now this is a simple quadratic equation. 18 2s are 36, so I see factors as 12 and 3, minus 12 minus 3. So 2a square minus 12a minus 3a plus 6, 18 equals to 0. I'm just splitting minus 15a is minus 12a minus 3a. That's how you do factors and do it. 2a into a minus 6 minus 3 into a minus 6. So the roots are a minus 6 into 2a minus 3. So a is equals to 6, a is equals to 3 by 2. 1, because I know a is x square, so x is plus or minus square root 6 plus or minus 3 by 2. Right, I figured out by solving this quadratic equation that a is 6 or 3 by 2, but I started off with assuming a is x square, right? X square is a, so that means x square is 6 or 3 by 2. If x square is 6, so x should be plus or minus 6, and x square is 3 by 2, x is plus or minus root 3 by 2. Sorry. So I finally end up with 4 roots, plus root 6, minus root 6, plus root 3 by 2 and minus root 3 by 2. As I said, expression with higher power of 4 should technically have 4 roots. So I have ended up with 4 roots, right? Even if you are not clear with this, stick to this rule of minus b plus or minus square root of b square minus 4ac by 2a. You should get the roots as 6 and 3 by 2. Once you figure out the roots are 6 and 3 by 2, this is how you should solve. So be careful if you see higher power, maybe there will be a simple logic like this, which is a quadratic equation, and just sort of try it. Right, this one is a cubic equation, x cube plus 5x square minus 2x minus 24. So we have sort of discussed about this on factoring in the basic algebra video. If you haven't watched this, strongly recommend to watch that to get your basics of algebra clear. Look at this. This is 1 and this is minus 24. So I need to have a product of minus 24. What are the factors of that? 1, 2, 3, right? 4, 6, etc, etc. Let me try one by one and see if any one of them satisfies. If x is 1, what would I get? 1 cube plus 5 minus 2 minus 24. This is not satisfying. I'll also try minus 1. You also should try plus or minus for all of this. If x is minus 1, what am I getting? Minus 1 cube minus 1 plus 5 plus 2 minus 24. Again not working. If x is 2, 2 cube 8 plus 2 square 4, 5 are 20 minus 4 minus 24. 28 minus 28, so 0. Yes, this is the root. So x is equals to 2 is one of the root. That means I will have expression like x minus 2 into a quadratic expression, and I can further split them to get x minus 2 into x minus something into x plus or x minus something, so that I have roots for them, right? So as I said, how would I find this? I should divide the normal division way. right? So now let me do this. X square, x into x square is x cube minus 2x square minus and then plus, they get cancelled out. 5x square plus 2x square is 7x square minus 2x. Now plus 7x. So 7x into x is 7x square minus 14x. You see, every time I have to change the signs for what I am multiplying. So that's when I cancel it. Plus, so 7x square minus 7x square minus 2x plus 14x is 12x minus 24. Plus 12, so 12 into x is 12x minus 12, 24. So minus and plus, they cancel, the remainder is 0. So you have to get remainder 0 because x minus 2 is a factor of this. So what am I ending up with? X square plus 7x plus 12. You know, I can solve this quadratic equation. I would be getting, I can clearly see 4 3s are 12, so 4x plus 3x. So the roots will be x minus 2 into x plus 4 into x plus 3. If you solve this quadratic equation, x square plus 7x plus 12, right? Let me do it in this minus b plus or minus format. B is minus 7, so minus 7 plus or minus 7 square 49. 4 into 12 into 1 is 48 by 2a. So 49 minus 48 is 1, so I will end up with minus 7 plus or minus 1 by 2. Minus 7 plus 1 by 2 is minus 6 by 2 is minus 3. Minus 7 minus 1 is by 2 is minus 8 by 2 is minus 4. The roots are minus 3 and minus 4, that's why I am getting x plus 4 and x plus 3, right? So this is 0, so the roots are basically 2, minus 3 and minus 4. Right? These are the roots of this equation, x cube plus 5x square minus 2x minus 24. Yes, a long approach, a tedious approach, no doubt about that, but this is how you should be solving equations of cubic, right? They could be easier by setting such a way that you can substitute the roots and check them easier manner, right? I could have gone ahead and checked for 3, 4 and I would have got even 3 and 4 in that way also. Even that is a possibility if I keep substituting, but it just depends on a bit of luck and time, if you keep trying things. How did I end up with trying 1, 2, 3, 4, 6? These are the factors of 24. And how did I come up with 24? Take this constant term and take this value. This is 1, so 1 into 24 is 24. So list the factors of 24 like 1, 2, 3, 4, 6. I can also have 8, etc. Start off from smaller. Check for both plus and minus, plus and minus, plus and minus. You should be getting all the roots in that, right? So if a and b are the roots of quadratic equation, find the quadratic equation whose roots are a square and b square. So they are saying 3x square plus 4x minus 7 equals 0. I can go ahead and find the roots by using minus b plus or minus b square minus 4ac by 2a and then do the squares of them and do it. What if I get the roots as 2 plus root 3 and 3 minus root 4? These are real roots, but these are not simple integers. They are like, sort of surds and some numbers. So a bit painful to go about this approach. Doesn't matter what the roots are. The easiest way is this. When you get to do is this. What is this expression? 3x square plus 4x minus 7. When ax square plus bx plus 7 equals to 0, c equals to 0 is the equation. The roots are alpha and beta. The sum of roots is minus b by a. Right? And the product of roots is c by a. This is what you need to understand. If you remember, I have said the equation can be written as minus of alpha plus beta into x plus alpha into beta equals to 0, right? This is how you write a equation if I know the roots. So you see this. So if I try to get this equation into this form, how would I do? Divide by a. X square by a is x square plus b by a into x plus c by a equals to 0. Still not of this form, so what will I do? X square minus of minus b by a into x plus c by a equals to 0. Now it is of x square minus something into x plus something. So now what is alpha plus beta? Minus b by a, right? And what is alpha into beta? C by a. That is what the simple thing is. If you don't know this, that's how you can look at this. Once I know this, if a and b are roots of this equation, so what are a plus b? What is value of a plus b? B is 4 and c is a, so it's minus 4 by 3. What about a into b? C is minus 7 and so that is a is 3. Now they are asking us to write the equation whose roots are a square plus and a square and b square. How would that equation look like? X square minus a square plus b square into x plus a square into b square. right? I know a square into a into b is minus 7 by 3. What is a square into b square? Just square 7 by 3, that is 49 by 9. So this is done. I need to find what is a square plus b square. That also I can do from a plus b and a into b. How? Square this, right? A plus b whole square is minus 4 by 3 square, and this will turn out to be a square plus b square plus 2ab equals to 16 by 9. What is ab? I know it, right? Minus 7 by 3. So 2 into minus 7 by 3, a square plus b square equals to 16 by 9. So 2 into minus 7 by 3 is minus 14 by 3. I send it that side, I will get it as 16 by 9 plus 14 by 3 equals to a square plus b square. Now that's the only thing that you need to understand. If I know a plus b and a into b, I can find out a square plus b square. This is the basic algebraic expression, right? A square plus b square plus 2ab. So ab is minus 7 by 3. I substitute it here, 2 into minus 7 by 3, so that I can find a square plus b square. Now if I'm just doing with the fraction, so it's 9, 16 plus 42, 58 by 9. So this expression would look like x square minus 58x by 9 plus 49 by 9 equals to 0. I can simplify it by multiplying with 9. So it will become 9x square minus 58x plus 49 equals to 0. Right? That's how we solve this. All I'm trying to say is this: once I know roots like a plus b and a into b, I can find for a square b square also like this. And that's how you have to think. If they give you, like for example, if they ask you what are the roots of, like what would be the quadratic equation if it is 1 by a and 1 by b, again use the same thing, x square by 1 by a plus 1 by b and 1 by a into 1 by b. So 1 by a into 1 by b is 1 by ab. I know ab, so I can find out 1 by ab. What is 1 by a plus 1 by b? b plus a by ab. I know a plus b, I know ab. So I can also find the sum of 1 by a and 1 by b. So you can do the roots like that. So that's how you need to solve questions like this. So thank you for watching this video. If you are watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of courses and also get to practice lot many questions after that. So you'll get a good practice and also help you to understand these concepts better. Also do like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of updates, with respect to the content that we are launching soon. So you'll get notified if you follow that page. So don't miss that out. So thank you for watching this video, and let's meet in the next video.